today we're going to do part 2 of 5-4 dividing polynomials. Today you will be able to divide a polynomial using synthetic division. A few things that we need to know about synthetic division before we get started. We must be dividing by a linear expression, x minus a. The coefficients, including zeros if we're holding any place values, of the polynomial must be in standard form. We're going to be getting rid of all variables and exponents, and for our divisor, we will be reversing our sign. So, problem number 1. Use synthetic division to divide, x cubed minus 14x squared plus 51x minus 54. This will be our synthetic division bar. And on the inside, I'm going to list the coefficients of my polynomial. 1, negative 14, 51, negative 54. So these are the place values that go with the polynomial. Then I take my divisor and I take the opposite sign. So on the outside, I'm going to have a negative 2. I bring down the 1 times negative 2. Which would be negative 2, put that there. And then I add down the column and I got negative 16. Negative 16 negative 16 times negative 2, which is 32. Add down the column, I get 83. 83 times negative 2 is negative 166. I add down the column and I get 0. Negative 220. Now, these are the coefficients of my quotient. They are going to be added to variables now. So this is our remainder. This will be our constants. This is x to the first power, and this is x to the second power. So your first term will always be 1 power less than your degree of your polynomial. And then it goes down by 1 each time. So our quotient would be x squared minus 16x plus 83, since that was our constant. Remainder, negative 220. We also could have written our remainder as minus 220 over x plus 2. Using synthetic division to solve a problem. The polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic inches of the shadow box shown. What are the dimensions of the box? Hint, the length is greater than the height or depth. So we have x plus 5 as our width. And we need to divide that to find our length and height. So I'm going to use synthetic division, put negative 5 on the outside. Since my coefficients are in order, 1, 7, negative 38, negative 240. Bring down my 1 times negative 5 is negative 5. Add down 7 plus negative 5 is 2. 2 times negative 5 is negative 10. Add down negative 48 times negative 5 is positive 240. Add down, we get 0. So that's my remainder. This is my constant. This is my x term. This is my x squared term. Therefore, my answer would be x squared plus 2x minus 48. Since I have x plus 5, I need to then, as my width, I need to find my length and my height. I know that my length times my height is x squared plus 2x minus 48, but now I need to factor this. So I would use the triangle, negative 48. What multiplies to negative 48 and adds to 2? And that would be 8 and negative 6. So I would have x plus 8 times x minus 6. And my last dimension would be x plus 5. So the dimensions of this box would be x plus 8 times x minus 6 times x plus 5. So our remainder theorem. If you divide a polynomial of degree n greater than 1 by x minus a, then the remainder is going to be equal to p of a. Or if we plugged in p, a into our polynomial, then we would get our remainder. So given that we have p of x is equal to x to the 5th minus 2x to the 3rd minus x squared plus 2, we need to find p of 3. So we can do p of 3 will be the remainder when we divide by x minus 3. So I'm going to use synthetic division, have 3 on my outside because I reversed my sign, and I'm missing a few. I'm missing the 4th, and I'm missing the 1st power. So I'm going to do 1 as my 5th power, 0 as my 4th power, negative 2 as my 3rd, negative 1 as my 2nd, 0 as my 1st, 2 as my constant. I then bring down the 1st, put it on the outside. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 2 plus 9 is 7. 7 times 3 is 21. Negative 1 plus 21 is 20. 20 times 3 is 60. 0 plus 60 is 60. 60 times 3 is 180. 2 plus 180 is 182. This last number is my remainder. Therefore, P of 3 is equal to 182. You could check your work by plugging in and evaluating your polynomial at 3. You guys try number 21. Divide using synthetic division. So set it up in our synthetic division box with 1 on the outside, which is the opposite. We have all of our powers, 3, 2, 1, 0. Put the coefficients on the inside, 1, 3, negative 1, negative 3. Remember, you bring down, you multiply, you add, you multiply, add, multiply, and